Okay, well, I think we'll get underway. Thank you for joining us. This is Dynamic CPD, where we provide a free webinars once a month for engineers and designers in New Zealand and Australia. And it's a free educational resource. And once this webinar is complete, it is recorded and it will be available online. So thank you for joining us this morning for our presentation on QPOD Earth-Friendly Foundations, which will be hosted by Peter Crawshaw from QPOD. Just before we start, just like to remind everyone that this information is general in nature and you must consult a chartered professional engineer or registered architect in the jurisdiction which you work in before applying this to any specific project. So with that, I will hand over to Peter. I will ask Peter to start with an introduction to himself and the product and the company, rather than introducing him myself. So with that, Peter, thank you, and take it away.
Thanks very much, Michael, and thanks for everyone joining this morning. My privilege to come on here and speak with you all and introduce you to a few things about QPOD. It's a little history on us. So I'm a general manager here at QPOD Earth-Friendly Foundations. We've been plastic moulding for the construction industry actually since 1988. My father starting the injection moulding division of the business then. And as we saw the raft foundations come to being in the early 2000s, we were supplying products into that industry and said, look, see all this polystyrene, the system works well, structurally it's a great system, let's make a recycled plastic version of this. So hence QPOD was born. So we're just going to look through some of these things today. So this is what we're going to have a look at. Why change? So just why would you change to QPOD? What is QPOD? Have a little bit of an overview and look at what is QPOD. The configurations, there's different configurations with QPOD. It's always interesting to see the different ways it can come together. Having a look at a case study, local here in Hawke's Bay. Having a look at some of the design details as well that you typically see with QPOD. And looking at green benefits. I mean, that's a lot of the purpose of what we've done is trying to reducing all the mess with polystyrene and using recycled plastics. And how to implement, how to use QPOD and the tools. So I've got a few tools at the end of this webinar I want to share. These are really useful in specifying and using QPOD in projects. Opening up to a Q&A at the end. Again, would like you to put the questions in the chat box. Just type them in there, and we'll seek to answer them either throughout the webinar or I'll collate them at the end if we get some repeat questions. So I really encourage you to put those questions in there. We'll try and cover off as much as we can today without boring you, keeping it interesting. But yeah, if you've got some key questions, we'd love to hear them and fire them in there. All right, so having a look at the challenges with conventional polystyrene. So we're familiar with it. Australia and New Zealand, we're using the system a lot with the raft foundations. We get a lot of this waste you can see right here on this screen. So these are all offcuts from a polystyrene raft site. So they're messy. They are environmentally unfriendly. They can be a nuisance on a building site blowing around. Can't deny that. Building green. So there's a pressure to reduce waste and carbon, obviously in New Zealand, and it's in place in Australia now more than New Zealand, ruling it out on building sites. So we're seeing that more and more, that change. So it's going to happen. It's just a matter of how quick we can embrace it. It is a proven raft system, and you know the polystyrene raft system works well. The rib structure, so we're not really trying to reinvent anything there. The hidden costs and freight, wastage, and tip fees. All those things, floating beams, when you're trying to do a polished floor, that could be an absolute nuisance. And the ability to absorb a lot of moisture. Polystyrene has the tendency to do that, which is not a good look for the future of our concrete slab. So what is QPOD? if I can just share a little on that, share this little video, which just runs through what it actually looks like on a site. So it is made of 100% recycled material and 100% recyclable. It is all a modular system as well, so it all comes together. Sorry about the lag in the video there. Giving us a bit of grief. But it does all clip together as a modular system. Just try that again. Apologies. Okay, so we're a bit stuck on that one. But yeah, essentially it is a modular system. It's got the built-in mesh spacer on the top here, and that gives you accurate mesh placement when you're placing that mesh down. And then obviously very stable when you're coming to pouring all that concrete and putting it together on the site. We'll have a look at a couple of configurations of the QPOD. It is one system of a bunch of components come together some different ways. So firstly, just sharing the raft system here. So this is the popular approach, I guess, and what QPOD has been largely built up on over the years. And this can be adapted in 220 high and 300 millimeters high pod. So that's given you effectively a 305 to up to 400 plus finished floor level. The raft system is great for poor ground sites, expansivity or reactive clays, and then liquefaction. Last year we actually went full circle back to our original concepts of QPOD and went about introducing the continuous system. This is where you can actually remove the ribs and run those pods continuous, a bit like what we saw in the video actually earlier. This has become increasingly popular with good ground sites around New Zealand. So this does perform on good ground conditions and then down to 200 kPa. And that, obviously, when it's into liquefaction or expensive grounds, is when we'd adopt the raft system again into an ECD design. So that's been super popular. Obviously, massive savings in steel and in concrete, being able to remove those ribs. Both systems are made up of the same components, so they all kind of fit together in the same set. Looking at some ground condition suitability, just got here a little bit of a brief overview for those interested in where this performs in ground conditions. So we've got the raft system on the left, raft systems. So that works on pretty well any ground, TC1, TC2 and 3 in the liquefaction categories of New Zealand. And then familiar with Australia and New Zealand, the expansive or reactive soils. That'll work obviously on M, H1, 2 and up to E class soils. So, and it all depends on what sort of steel and strength is generated into the concrete in that design. Over on the right, we've got the continuous system I mentioned. So that's suitable essentially in the TC1 category in New Zealand, and then into expansive and reactive soils limited to A and slightly or S soils. So anything beyond that would go into raft, and then on the continuous system, obviously that's allowable down to 200 kPa ultimate bearing, whereas the raft will go down to 150 kPa ultimate bearing. And I have seen it even go lower with specific engineer design. However, generally we're not talking ground too much less than that on building sites in New Zealand and Australia. Just having a little look at a case study right here in Napier actually. So assuming it's all around New Zealand, but this was one that had a lot going on. So we just wanted to share that. It was a TC3 soil site right on the shorefront, multi-story and a lot of features. So I just wanted to run through that as a good example to share. Here was the plan here. You can see a lot of thickenings throughout. This actually shows really well where the QPODs are very adaptable. You can see the pods are broken up to meet those thickenings. You can see the extenders marked as the little green items. probably actually see them in my background of my video. If I just tilt it a little bit, you can see in here in my video, you can see the extenders right here, and they create your adjustment for meeting up with thickenings, perimeters, alternates in the slab, and really just giving you a whole raft of options to fill that layout. So you don't have to do these layouts, we do these for free. So all you do is design the slab and we'll infill it with these components. We'll do this overnight for you. Just send your plan through. Hey, we'll put QPOD in here. We want to do the raft system. We want to do the continuous system, whatever it is. We've got some shower recesses. We've got some insulation in here, and we'll do the rest. So that's something we will offer. So welcoming you to engage us on that one. Got a little video here just to share some of these non-standard details. Today we're going to share a couple of non-standard details that you don't often see on sites. Come and have a look. Wing wall footings, elevator footings, embedded steel structures. We actually see these quite often, but recessed showers. Those are a couple of common little things that you see on a, or you wouldn't often see on an average site. So we do see recessed showers on a lot of sites, on typical homes, but elevator footings, bulk load footings, I mean, they're all possible with the QPOD system. Looking at some green benefits. So everyone thinks, green benefits, recycled plastic, it's going to cost a whole lot more to be, make that eco-friendly approach. It doesn't have to, and this kind of points it out. So we've got styrene slabs in the middle there, QPOD on the right. Obviously, all the factors of polystyrene creates waste, a lot of logistics, not that recyclable, and eco-unfriendly manufacturing. So over on the right, we've got QPOD, we've got no waste, 5 pallets on a typical site of product, and made from 100% recycled materials. So you can sort of see the price difference there, $200, $208 per metre squared. For each, so you might take out $8 more. Where does that come from? The pods are actually quite similar, sometimes fractionally more than polystyrene, but you've got some advantages. You've got a built-in bar chair on there, so there's no extra components there, and then you've got a little bit of extra concrete going into the structure, so that is a little bit of a cost factor, hence the $8 more on metre squared. That extra concrete is a bonus, so we're finding with sites we're getting builders' feedback saying they're getting a lot less cracking, or if any cracking at all, with the QPOD sites, just because of the shape. We haven't got those straight edges that create like a crack inducer, if you like. I know raft slabs are great. We have very little cracking at all generally. QPODs even excels on that, so great bonus there.
Sorry, Peter. Just before we go, we just got a question just back on our Harding Road case study there, just from Geert. He's just wondering, was that done using the continuous system, or was that with the raft system?
Yeah, sorry, the screen's not quite showing clear enough there, but that's the raft system. So that was TC3, and most certainly raft in there. I don't think continuous would have cut it for that ground condition. So that. Yeah, I think we'll, if you can look close, you can actually see the rib structures in between the pods. The ribs at 1200 centres, correct. Yep, the I've answered that. Phil, have I, Sam?
Perfect, yep, thank you. And just one other question to hear from Mark as well. Is the cost difference you mentioned of poly versus QPOD, so the $200 versus the $208 per square metre, just for the materials? Or are there any sort of is the cost difference the $200 versus the $208 square meter? Is that just based on materials, or are there any sort of labour savings as well, or any other savings, I guess, with QPOD?
Yeah, good one. Yeah, so the 208 is purely material and install labour cost on site. So you can add on to that. So there's a pure cost there. We can add on to that. All right, we've got no polystyrene waste to pick up or to take back to a recycling depot or a polystyrene collection plant. And then secondly, you've got no polystyrene blown away on site. So those pods, those 5 pallets, they could be delivered last week, the week before, and they'll still be sitting there now. Nothing's blown away. So reason people are paying $8 more a square metre is they've got these advantages. They've got a modular system. They're not having to muck around with all these offcuts and cutting it all, for that matter. So yeah, there is some labour savings there. We do have contractors saying this is faster now that we're using QPOD. However, for a first-time user, often takes time to get used to those things. So yeah, great question.
Just got a couple more. Sorry to dwell on these slides here, but just can we also just clarify, just coming back to the Harding Road site as well, I guess. Just the thinking around, typically for a liquefaction prone site, that ribs are required between each pod, i.e. ribs at 750 mil centers. Can you maybe just sort of elaborate on that a little bit?
Yeah, so the option of doing rib centers at 750 is not an option with QPOD. We are limited to 1,200 rib centers. So in terms of getting that strength back again in the ribs, yeah, it comes down to the steel in the ribs. So you might be looking at more steel than a typical TC1. So you might be up speaking the steel or going to rib bars, and then right up through into the expansive grounds, medium and extreme. We'll be looking at putting some shear steel in there, so whether that be stirrups or fibre in the concrete. Obviously, the latter being the preferred. Hope that answers the question there.
Great, yeah, and great questions, guys. Please just keep firing them through. Just one last question, Peter, as well, just before we sort of zoom on here. So, on average, for a typical foundation, what additional percentage of concrete goes into the QPOD system? And has QPOD calculated the added carbon cost associated with this additional concrete?
Yeah, very good. Percentage-wise in the concrete, I think I could be corrected, but I think it's 3%. So yeah, there is a carbon factor there of that 3% of extra concrete given. So yeah, that is a point. Then you can look at the reduced logistics, I guess. So you've got five pallets as opposed to a trailer load of polystyrene coming up. So you've got some carbon reductions there in the transport, and then obviously the recycled plastic that it uses. So yeah, it's a bit of give and take there. Trusting that helps.
Great, yeah, thanks, Peter, and yeah, everyone, please feel free to keep popping those questions in the Q&A.
Perfect. Yeah, thank you. All right, so moving on to some of those design details which we started touching on. So what you typically see in a perimeter beam, so this is just straight out of the box for a good ground, so SE62 mesh with 3 perimeter bars of HD12, and then your hockey stick bars at 1100 to 1200 centers, depending if it's raft or continuous system. And you go anywhere up from here with the ECD designs. Obviously, you got all that standard detail on our website to pull down at your leisure. Internal thickenings, typically again, good ground, two bottom bars in those thickenings for load walls, load points, point loads, and line loads. Point loads for perimeters, so when we're getting over 30 kilonewtons, we can obviously put a load bearing pad in there. This is getting into SED territory. The example image on the left was actually a rural barn. Actually, they were putting 8-ton trucks in there, so that was the demands. So that was a raft slab. I think they went slightly bigger ribs on that one, 150mm ribs, if I'm not mistaken. So it's all quite adaptable to different scenarios that engineers come up with around New Zealand and Australia. Wing walls. This is a great question we get a lot from architects, and this is an option that we've got a lot of standard detailing on within our code mark, which I didn't actually mention earlier. So We do have a code mark on the system as well, and that makes it available for architects to design this within certain design parameters. So if those design parameters are met, they can include things like wing walls as shown here. Bit of an example of that. Recessed showers, obviously another one we see on a lot of standard sites as well. You can see on the picture on the left, we've got some recessed pods in there. So we supply them to site based on that layout that we provide. We work out how many you need, and so the builders don't have to muck around and cut them down, or they can just follow the plan and put them in. Services for pipe work. So typically we see services installed subgrade and just having vertical penetrations like we see in the middle image there. This is what we see for the most of slabs that are done in New Zealand and Australia. Over on the left, we've got in-slab services. We see a little of this in Christchurch from time to time. And that, again, you can run the pipes underneath the pods quite simply because they're just a hollow void of air. But yeah, so pretty much you have those vertical penetrations. You come along with your pods, cut a hole in it, and then slop that over top of the services. And then just putting some expanding foam around the cut if there's a bit of a gap to stop concrete going in there. Obviously putting any extra trimming bars in there just where the mesh is cut as shown. And then rib and foot penetrations, we're just creating that perimeter thickening again where those penetrations are. So just taking a couple of pods out, putting some of those extenders in. They just create your adjustment. You can see the picture on the right there. And then you can run your steel around those.
Peter, just a couple of questions, and we might have actually just covered off the answer in this last slide here, but just we got a attendee here that's they missed the first few minutes, but can you maybe just elaborate on what the pod is actually filled with, and then also are they fire resistant or fireproof?
They filled with. I'll just jump back to the slide here because this pictures the pod quite well. So this is a recycled plastic pod joined as a group of 4, and then inside here is an encapsulated pocket of air. So that's I've got them right behind me here on the scene as. They've got to be built structurally so contractors can clamber all over them. And as you can see, straight here. You can really jump up and down and they're not going to go anywhere. So that's a hollow void of air, but it's all structurally strengthened by that shape of ribs and ribbing. Fire rating. So this is a plastic pod in the concrete foundation. In terms of a fire rating for the plastic, PP, which is made out of recycled PP, will burn. But essentially this is a void filler under the foundation, so there's actually no exactly fire test or rating needed or been done there. I hope that helps on the question there, Sam.
Perfect, yeah, thanks Peter.
Cool. Sam, I've just got a sample here. I'll actually show you. This is one made out of recycled bottles. It's completely clear. So we ran a bunch of these a while ago. We had a lot of soft drink bottles coming through in our recycled material. And so we ran these clear ones, which are pretty awesome. You see right through them. They went out to sites around New Zealand over the last couple of months ago, I think, wasn't it, Sam?
Yeah, that's correct. Yep. Yeah, they look pretty cool on site.
Cool. Thanks for the questions. And yeah, by all means, pop them in and we will cover anything off that hasn't been already at the end. Some of the resources I just wanted to share with you that are available from us on our website. We've got the layout service, which I before mentioned. So we'll do that for any designs where QPOD is specified. That gives you accurate component count and layout, making it super easy for the builders and contract stores ordering the product. R value calculators, so this is an important one, just measuring what R value this does produce. So we've got them on the website as well. And then standard details, obviously they're all there for continuous and raft systems. And the design manual. So if you're following that design manual within its design parameters, so that's a code mark manual, you can also adopt the continuous system following that manual. So that does have all the parameters of what ground it works on and multi-story buildings and what level of loads. And then outside of that, it goes to ECD design. So scan that code there, you can get all those resources you want. Just having a look at the R value calculator on the website here. Just wanted to share this with you actually. So if we just dive into the menu there, look on R value calculators, and we click on verification method, put in our area meters squared and our linear meters of the perimeter, giving us a area to perimeter ratio. Tick our boxes, then we can refer that area to perimeter ratio down to our table here. And we can see some different options of what R values will get with under slab insulations, no insulations, sidewalls. So some different options there of what R value you'll get. And you can choose for your different QPOD systems up the toggles. Yeah, and obviously in the resources, so we've got all our manuals there, our standard details, 3D files if you want them. So you should find everything you need there, certificates and the likes. Cool. A little taster for coming up. We can't share everything today, but we've got another webinar next month. And this is on a slab tank water attenuation system. So this is for storing water in the slab or in the driveway or under a deck. It's close on 1,000 litres per tank there with no in-slab connections. This is purely keeping all those connections outside the slab, reducing your risk, your labour time, and then opening it up to any plumbers being able to install this. So this is a really exciting one for us. Make sure you don't miss out on that webinar. So that's the scan code there. So that pretty well covers what I wanted to share today. There would be other stuff you want to know, so please reach out, and please, if you've got questions, pop them in now, because there's still that opportunity. We're going to stay on here and answering those questions that haven't been answered already. Hoping you can pop them in. Does anything come in there, Michael?
I've just actually got a few things myself I'd like to ask about, just from my experience in it. Firstly, how much concrete cover? I notice you've got those little built-in bar chairs, so you don't have to add anything extra there with the mesh on them. And then how much cover do you have over that mesh?
Yep. So minimum is 85 millimeters from the top of the pod to the finished floor level, and that built-in bar chair is sitting up proud 40 millimeters. So it's sitting your mesh right in the middle of that topping. That built-in bar chair is a patented design of QPODs, which puts that mesh right where it needs to be. Some of the other systems out there don't actually put the mesh right in the middle of that topping, which is concerning for designers of foundations. So 85 is the minimum. You can obviously extend that up wherever you like. So when you're starting to get anything above, say 120 millimeters or 130 millimeters of topping, you might start needing to prop that mesh up a little higher in reality.
Yeah. Just and while speaking about concrete, so if I specify a QPOD system, do I have to buy my concrete from a certain supplier?
Yeah, it's an awesome question. The answer is no. As we are independent, QPOD is manufactured and designed by QPOD, distributed by QPOD, so you're open to using certified concretes of your choice.
Sam, have you got anything else to? I've got a few more questions, but have you got anything, Sam?
Yeah, just another question, Peter. Can maybe just slide back to that slab tank webinar page? We just got someone that wanted to zap the QR code so they could sort of register for that.
Get back to that one. It's visible there, is it?
Perfect, thanks.
Yeah, I'll leave it on there. You're welcome to scan that. That will give you an invite to the next webinar we've got the end of next month, July 31st. This is a super exciting one too. So we'll try and keep QPOD out of that one, or focus completely on water storage.
Just if I could just, there's a lot of attendees are from New Zealand, but we've got some from Australia, and they may not be familiar with the terms TC1, TC2, and TC3. Those are terms that don't come from the Australian standards directly. They are terms that came out of the Christchurch earthquake sequence as a way of categorising different types of ground, and they have become regularly used through the whole of New Zealand now, but not so much Australia. So it's really categorising ground into we have good ground, which is an ultimate bearing capacity of 300 kPa, allowable bearing capacity of 100 kPa, but that excludes anything with liquefaction potential or anything that's highly expensive. And those TC1, 2 and 3 categories are just a way that the New Zealand profession sort of categorises different foundation types. So just for a few on there that are not familiar with the New Zealand terms.
It's largely around the liquefaction and the settlement of the ground in an event of that ground moisture. I guess it's lesser of a risk in Australia, is it, Michael? So much of that wetter ground.
Yeah, and the most of Australia has a lot lower seismic requirements than New Zealand, but yeah, there's still all sorts of soil conditions. So yeah, the flexibility of the system must be a great thing for a designer, I can see.
Absolutely. Thanks for clarifying that.
Perfect. And just a couple of other questions too, Peter, if we may. Just Mike wants to know, can you elaborate on the reinforcement requirements for the raft system versus the continuous system, please?
Yeah, so just ducking back to that raft page. So typically for the raft, the main difference is obviously the ribs versus no ribs. Continuous not having the ribs, the raft having the ribs at 1200 centres. So the perimeter details look much the same for both. You've got by minimum 3 perimeter bars of HT12, and then by minimum 1 footing rib bar, and then 1 hockey stick at the rib termination. So anywhere up from that is the standard raft detail, 4 perimeter bars, 2 rib bars, etc. And then the continuous, again, that would be the perimeter details much the same, minimum 3 HT12 bars, the hockey stick bars at 1100 centres, so in between every second pod. That ties the topping into the footing. And then you wouldn't go any more than that, because at any stage you'd be going to raft if you were generating more shear strength.
Perfect. Thanks for that, Peter. And just one other question as well. How long has the product been around for, and what's the feedback been like from sites?
Perfect. Yep. So QPOD has been around for 8 years and developing before that as well. And it's been growing year on year around New Zealand. So we ship it all around New Zealand now and launching into Australia at the moment as well. It's now available in Australia. So feedback from site, I mean, we get raving fans, don't we, Sam? That would never choose anything else. I mean, what do you want me to tell you? But yeah, no, it works well. It's been said as the strongest. There's other plastic pod systems out there, and we're all together, I guess, in the sense that we're reducing the polystyrene on sites, and I love that. We're all doing the same thing. But it has been said about QPOD, it's the strongest one to walk on sites. That's feedback from contractors who tell you the truth when they're clambering up and down on these things.
Perfect. Yeah, thanks for that, Peter.
Just one question that it hasn't been asked this morning live, but I've had it many times, just as to plastics and microplastics. So there are some clients who don't want to bury plastics in any way, shape or form. It's just really important to point out that the alternative of the polystyrene pods are one of the worst offenders we have for getting microplastics into the environment. So it's way ahead of that. The other thing to bear in mind is that microplastics either come from primary microplastics, which are made that way, like made as little beads, or secondary microplastics, which is when a plastic product breaks down in the environment, and it will either break down generally through UV exposure or through abrasion. So these pods, once they are installed, they have no UV exposure and no abrasion. So their design life is actually indefinite, so significantly longer than the design life of the structure itself. So there is no chance of microplastics from these pods, and that is in stark contrast to some of the alternatives that get used. So I think that covers the questions from my end, Peter.
Yeah, thanks, Mike.
Peter, I just sort of jotted down a few questions as well, and mindful of and very respectful of everybody's time, but maybe we can just sort of cover off from these in a minute or so. But I sort of jotted down a few questions that we get sort of fairly regularly, I suppose, from the engineering community about sort of how do you actually design QPOD?
Yeah, that is a great question. So most of you would be, most of the engineers on the call would be familiar with designing raft slabs with the polystyrene pods and the calculations associated with that. So this being a same dimension as a polystyrene pod, so 1100 by 1100 by 220 or 300 high, you can apply those same calculations to it and just say, hey, we're using QPOD in here as a void filler instead of polystyrene. In the case of the continuous system being a little bit unique, there not having the rib structure, we have got a design manual for that, and that sets out clearly all the design parameters and performance limitations of that system. So you can download that freely and apply it freely to your projects. Follow that guidance. Cheers for that.
Perfect. Yeah, thanks, Peter. And just a couple of other questions just to round out as well. How do we sort of achieve shear strength for expansive soils?
Yes, and I did cover on that slightly, or you might have picked up when I was mentioning about the stirrups and the fibres. So when we get into M and E class expansivities or reactive clays, we often see the use of extra shear steel required. Obviously, firstly, you'd be putting more steel in the reinforcing and in the mesh, and then extra to that, you may need to go to the extent of putting stirrups or fibre in. The latter being by far the most preferred option by all. We have done a few with stirrups, and that's purely because the client, they wanted a polished floor and they did not want fibres shown in it, so they had to do stirrups. But boy, oh boy, the labour with stirrups is it's not very friendly to the contractors. So fibre is the way to go there if you can.
Absolutely. And just one last question, Peter. Failing any more questions from our attendees here. Just I guess one that we get quite a bit is just sort of how do we compare in terms of QPOD versus poly in terms of R value?
Yes. So the R value calculator has obviously got the QPOD R values, and the polystyrene being a dense product with a dense wall, and QPOD being a hollow thin wall product, there is a difference there, and it is erring on the advantage of polystyrene and the insulation factor. So on a typical site with no insulation, a QPOD site might get say 1.3 R value, and a polystyrene might get 1.35. The difference being about 0.05 between the two. So it's very negligible, and it is worth just noting There is a little bit of a myth out there around plastic pod floors, maybe not achieving R value or not achieving a high enough R value. That is, help yourself to those R value calculators that have been verified and tested. You'll find the difference is very negligible. Although it's there, it's very negligible. Cheers, Sam.
Perfect. Yeah, look, thanks, Peter. And just one last question as well. Where's QPOD manufactured, and where does the recycled plastic originate from? We're just sort of keen to understand if it is reducing waste locally, I suppose, or more sort of are we taking waste from sort of overseas and doing something with it? Sort of, how does that work? Maybe just elaborate a little bit around that.
Certainly. So we manufacture all the QPOD in Napier, Hawke's Bay. The manufacturing facility is here. We source our recycled plastics from a source of a range of different plastics, mostly recycled polypropylene, and then also recycled PET, which is your soft drink bottles. The PET is all sourced from New Zealand waste PET, post-industrial, and then the PP is partly sourced in New Zealand, partly offshore. So some of that comes from car recyclers offshore, which they reprocess plastics and into a bead and send it out here for use.
Perfect. Thanks, Peter. I don't think there's any more questions, but if there are, Peter will touch on. We're going to sort of follow up with some communication out to attendees today. So I'll leave Peter to cover off on that. But back to you, Peter.
Absolutely. And I just really want to say thanks for you all joining today. And before we go, Michael can wrap up. Thank you for Michael for making this available. We're really excited with the way QPOD's going. We just see it growing and growing in New Zealand and Australia now. We're going to see it growing in Australia throughout next year as well. And then, really looking forward to maybe seeing some of you again next month on this water attenuation. Any resources that will be going out after this, Michael? I think we're sending out something to all the attendees, aren't we? Can you clarify on that?
Yeah, thanks, Peter. Thank you for presenting today. And as you say, the QPOD team will follow up to everyone that's attended with just some information. And we can also include a link to next month's one. We will be also advertising that a bit closer to the time. And the webinar will also be available online over the coming weeks, and it will have, in addition to it, a little knowledge quiz, and you can actually get a certificate for a record of your professional learning as well. So I think that wraps us up now. Appreciate everyone joining. Watch out for the follow-up email from the QPOD team. Thanks.
Cheers, Michael. See you all. Good to have you on.